Hello students, today we are discussing rotational motion problem. A wheel starts rotating from rest and attains an angular velocity of 60 radian per second in 5 seconds. The total angular displacement in radian will be. Since the wheel is attaining 60 radian per second, omega final equal to omega initial plus alpha into t. So alpha is 60 upon 5. This is 12 radian per second square. And what is theta? Theta equal to half alpha t square. This is 6 into 25. This is 150. 150 radian. So out of 4 choice, the correct choice is option 4. Out of 4 choice, the correct choice is option 4. A body rotates 300 rotations per minute. The value in radian of the angle described in 1 second. 300 rotation per minute means this is 5 rotation per second. In one rotation, angle is 2 pi. So this is 10 pi radian per second. So out of 4 choice, the correct choice is option 4. Option 4 is the correct answer. The moment of inertia of a solid cylinder of diameter d and length L about an axis perpendicular to the length and passes through center of gravity. This is the situation. This is a solid cylinder. This is its geometrical axis. Length is L. And we have to determine about this axis. So about this axis, moment of inertia is m L square upon 12 plus R square upon 4 plus R equal to d by 2. So this will be the answer. Out of 4 choice, the correct choice is option 2 is the correct answer. 3 solid spheres of mass m and radius r are shown in the figure. The moment of inertia of the system about x dash axis. Dear student, for this sphere, this is tangential axis. For this sphere, this is also tangential axis. And for this sphere, axis passing through center of mass. Moment of inertia of solid sphere is 2 upon 5 mr square. About tangential axis, this is 2 upon 5 mr square plus mr square means 7 upon 5 mr square. So 7 upon 5 mr square into 2 plus 2 upon 5 mr square. Why 2? Because there are two spheres. So 14 plus 2, 16 upon 5 mr square. This is the answer. Out of 4 choice, the correct choice is option 3. Option 3 is the correct answer. 4 similar point masses, each of mass m, are placed on the circumference of the disk of mass capital M and radius capital R. The moment of inertia of the system about normal axis through center O will be. This is mr square upon 2 plus 4 mr square. So out of 4 choice, the correct choice is option 2. On the marks of 20 centimeter and 70 centimeter of a light meter scale, weights of 1 kg and 4 kg respectively are placed. The moment of inertia in kilogram meter square about the vertical axis through the 100 centimeter mark will be. Moment of inertia will be equal to, for 4 kg distance is 0.3 mr square. For 1 kg distance is 2800. This is 0.8. If we solve this, this is 4 into 0.09. This is 1 into 0.64. If we solve this, this is 0.36 plus 0.64. So answer is 1 kilogram meter square. So out of 4 choice, the correct choice is option 1. Option 1 is the correct answer. The graph between the angular momentum J and angular velocity omega will be J equal to I omega. So graph is option 1. Option 1 is the correct answer. The acceleration down the plane of a spherical body of mass m and radius r and moment of inertia I having angle of inclination theta. This is g sin theta upon 1 plus k square upon r square. Multiply mm, so this answer will be I upon mr square. So out of 4 choice, the correct choice is option 3 is the correct answer. A sphere rolls down the inclined plane through height h. Its velocity at the bottom would be v equal to under root 2 gh, since acceleration equal to g sin theta upon 1 plus k square upon r square, and s equal to half at square. So t equal to what? 2s upon a. So we can find v square equal to u square plus 2s. We can find v square equal to 2as. A means g sin theta upon 1 plus k square upon r square s. Okay. S sin theta equal to h. So 2gh upon 1 plus k square upon r square. So v will be what? This is also in under root. For sphere, this is 2 upon 5. So under root 2gh upon, this is 5 plus 7 upon 5. So option will be under root 5 upon 7. Velocity at the bottom. This is 10 upon 7. Under root 10 upon 7 gh. Out of 4 choice, the correct choice is option 4. A ring takes time t1 in slipping down an inclined plane of length L, whereas it takes time t2 in rolling down the same plane. The ratio of t1 and t2. First find, this is the acceleration for slipping, and this is the acceleration for rolling. G sin theta upon 1 plus k square upon r square. This is the case of ring. So this is G sin theta upon 2. Now, time is being asked. S equal to what? Half at square. So T is what? 2s upon a. S is same. So T1 upon T2. This is T1 and this is T2. Equal to what? Under root A2 upon A1. So this is 1 upon 2. So this is the option. Out of 4 choice, the correct choice is option 2. Option 2 is the correct answer. The angular velocity of a body is omega equal to 2ik plus 3jk plus 4kk and torque equal to ik plus 2jk plus 3kk acts on it. The rotational power. Power equal to tau dot omega. Make the scalar dot product. We will get I cap dot ik1 2, j cap dot jk1 6, k cap dot kk1. This is 12. This is 20 unit. So out of 4 choice, the correct answer is option 1. 3 thin uniform rods, each of mass m and length l, are placed along the 3 axes of a Cartesian coordinate system with one end of each rod at the origin. The moment of inertia of the system about z axis. See, if this is z axis, moment of inertia of this will be 0, because the axis is passing through this. And for this is ml square upon 3. And for this is also ml square upon 3. This is x, this is y. Okay, so answer is 2ml square upon 3. So out of 4 choice, the correct choice is option 2. Moment of inertia of a cylindrical shell of mass m and radius r and length l about its geometrical axis. This is direct ring, okay, a bar square. So out of 4 choice, the correct answer is option 1.